Okay, so we've got other matching working and we've got bombs working in the game as well too. But one thing that can happen if the player plays for long enough is that you can potentially end up in a situation where there aren't enough matches left on the board. There's no matches for the player left to do. So we don't want that situation to ever occur. It can take a while to happen sometimes, but it can definitely happen in the game. So what we want to do is give the players the ability to shuffle the board around whenever they can't find any matches in the game. So they don't end up in a situation where there's nothing that they can do. There's nothing worse than that happening, basically. I know I've played a good few match 3 games, and I always preferred the ones that have this shuffle mechanic in it to allow you to keep playing the game, versus ones that say, oh, you've no more moves left to do, you just failed the level. That's not as much fun of an experience. So let's go to our board script here, and we're going to add a new function in down the bottom. We're going to create a public void that we're going to call shuffle. Actually, no, we'll call it shuffle board, so that we know we can shuffle the board and shuffle the position of everything. And how we're going to call this, for now, we're going to add in our update loop, we're going to just check if the player presses a key on the keyboard. So I'm going to say if they press the S key, it'll shuffle the board. As we go a little bit further, we'll add a UI button into the game that we're going to that's going to actually control doing this. But for now, we can just have it set up like this to make it easy for us to test it out. So we're just going to say if input dot get key down, and then in brackets key code dot S, so S for shuffle. If the S key is pressed down, then call the shuffleboard function. Okay, so let's go back down to our shuffle the board, and we need to check and see what do we do with this. Well, basically what we want to do is we want to get all the gems that currently exist on the board. So take all the ones that we have here and just add them to a little list, because we don't need to know the positions of them anymore. We're just going to put them all in new positions. And then we just need to loop through all the available spaces and place the gems into place. And one thing we also want to do is try and make sure that there's no matches out of the gems that are in here. But there is a good chance that some matches could be made, simply because unlike when we're spawning in gems, there's only so many gems available for us to place. So there's always a chance that, especially up in this area, we could end up with a match being made. So let's stop this. Let's go back in here. So the first thing we want to do is get all the gems from the board and add them to a list. So what we're going to do is, as soon as we press shuffle the board, we don't want our players to be able to shuffle loads and loads of times in a row. So we're just going to say if the current state of the board is not waiting, because obviously we don't want shuffling to happen while the gems are supposed to be falling down. So if the current state is not in the wait state, well then first thing we want to do is set it to be the wait state, so that the players can only press shuffle once and then have to wait for it to finish. Then we're going to create a list of gems that we're going to call gems from board, and I'm going to set that to be equal to a new list of gems. So it's a new empty list that we've created. Then we're just going to loop through our entire board. So let's get our X and Y for loops here. I'm just going to copy and paste them in here, so we can just use that again and close those brackets. And then we're going to say if for every gem we have, so every gem on the board, we're going to get our gems from board list. So gems from board dot add, and we're going to add that particular gem. So all gems at position X and Y. And then we're going to say that gem on position X and Y, or sorry, that position on the board should now be null. So we're making it null doesn't destroy the item, it just removes the reference to the actual gem itself. So that's how we'll add them all to the list, and then at this point we'll have nothing left assigned on the board itself. And then we're going to say here, now we need to add them back in to the array one by one. So again, we're going to use our for our two for loops for x and y. So I'm going to copy that again, and I'm just going to remove this bit in the middle, obviously, because we don't want to do the same thing again. Now, you might be wondering, well, why are we doing the same for loop twice? The first for loop is to strip them out, and the second for loop is to put them back into place. You might think, oh, well, we could just do it all in one go, but we need the board to be completely empty before we can fill it back in again. Okay, so in here, we're going to say, okay, pick a random gem to put into our board. So we're going to say int, oops, let's try it again, int gem to use is, much like we did at the very start when we were spawning in our gems, is random range between 0 and gems from the board dot count. So we want to, sorry, I said much like we did before, I meant in terms of we picked from the gems array that we had. What we want to do this time though is pull it from the actual full length of the gems that we've added to our gems from the board. And then we're going to say while there are matches. So this is like what we did in the setup function, where we had the while loop to check if there was any matches when we placed the gem. So we're going to say here, we want to place these and hopefully not have any matches. So while there are matches at a new vector2 int of x and y, while there are any matches there, then, or sorry, while at this position, the gem we want to check, of course, is from the gems from board list at the position, the random position we selected of gem to use. While that's true, then make it randomly pick a new gem to use. So I'll copy this and paste it in here. And then we would continue on, and we should hopefully pick a random gem. But if you remember, while loops are really something you have to be very, very careful with. And we want to be extra careful with this because there's only so many gems in our board. So if we get to laying out the gems on the board and say they randomly shuffle around, and at the end we're left with two red ones here, we've got two red ones here, and it's added all the gems in, and it gets to the last slot, and the only gem left is a red gem to spawn. Currently with the while loop we have set up, it would say, oh, well, they match, so try and pick another one. But there's only one in the list, so it'll just get stuck forever trying to pick the same one. So much like we did before, we're going to use the iteration system to make sure that we can put a limit on it, and if it gets to 100 and it still can't find a different gem, then it'll match and it'll be perfectly fine. It doesn't matter. So we're going to say int iterations equals 0. And then in our while loop, we're going to say while this is true and iterations is less than 100. Again, you could put this at a smaller number if you wanted to, but that'll be perfectly fine for right at the end of it. But what we're also going to do is make sure that, hey, if there's only one gem left to pick, just pick that gem. So we're just going to say here, and the gems from the board dot count is greater than 1. So we're saying as long as there's more than one gem in here, you can randomly pick another one, but if there's only one left, that's the only one we can do, so you have to pick that one. It's just to make sure, otherwise, no matter what, it might try and get to 100 with this last position, so we don't really want that. Okay, so with that done then, we then need to say within the while loop that iterations should be ++, so it'll add 1 every time it runs through. And now when we get to here, we should have a valid gem that we can use. So then we're going to say, first of all, we want to set up that gem. So you remember we had back in here, we had setup gem, which would set its position index and it would store the board as well. We're not too worried about storing the board, but we do want to set the new position of the gem in the array. So we're going to say our gems from board list, look at the gem to use, so the gem we're about to give a new position, and we want to set up that gem, and where we want it to go is the new vector2 of x and y, the new point we're looking at. Of course, we also need to tell it that this is the board that you should be using. And then we're going to say on the actual board itself, put that gem into that slot. So all gems at position x and y is equal to the gems from the board at gem to use. and then we're going to remove that gem from our gems from the board list so that it won't be randomly picked again. So here we're going to say on the gems from board, I'll try that again, gems from board list dot remove, dot remove at, so we want to tell it remove at a particular position from the list, which is the gem to use position. So whatever number our gem to use is. Okay, so that's all fine and dandy. Let's just say this, there's one extra thing we want to do with this, but let's just leave that for the moment. We're going to let that save and go back in here. And if I go and play now, we should see when I try and shuffle the board. Oh, sometimes it likes to add a little bit of a weight before playing. Don't know why Unity occasionally likes to do this. It's obviously trying to catch up with something behind the scenes, catch up with compiling something. There we go. So if I hit S now, there we go, we get shuffled all around. Oh, one gem randomly got assigned to the exact same position it was in. So that's obviously just kind of funny. Now I could only do one shuffle there because we set it. Now I could only do one shuffle there because we set it to wait at the start of our shuffle board. Which is perfectly fine. It doesn't matter if we do that. Let's just stop and run this again, because what I want to do is demonstrate that okay, we're not getting any matches here, which is pretty good. We're not ending up with any matches in place, but I want to see what can happen if we do get a match, because there is always a potential for a match. There we go. So we got a match up here in our purple area, but right now nothing else has happened. We're not going back to having no match, or that match isn't getting destroyed like it should be. So we obviously don't want that to happen. So as I said, I said we had one extra thing to do, which is that at the end of our shuffle the board stuff, then in here, so we want to make sure it's still inside this if statement, but after our for loops have all taken place, right here we just want to stay start coroutine fill board co. So you should remember our fill board coroutine. If we go back up here, where are we? There we are. It'll refill the board if it needs to, and then it'll find any more matches, and then it'll check if it should destroy those matches. And if it does, it'll go through the whole process all over again. So that's what we want to have happen when our gems are shuffled into place. So let's go back in here now, and we should be able to see this time. I'll be able to shuffle and continue shuffling over and over again if I want to. So if I shuffle, there we go. It takes a second to go through the process. Let's see if we can shuffle enough to get a match. There we go, we got a match. So then new ones drop into place. So perfect. That's our shuffling system working nicely.